You have about 40 minutes, 45 more or less.
Okay.
And then we have plenty of time for questions.
Okay. Well, thanks, Ekain. And thanks the rest for being here. I promise it's going to be an interesting talk, or at least I will try to do that. So here's the topic, what I want to talk about. It's basically a pretty old theory, namely natural kind essentialism, but I will do it from a formal point of view. And the specific aim of this talk is to introduce a formal semantics for natural kind terms, and specifically for a theory, for an essential theory of kinds formulated in classical logic. So more specifically, it says two-sorted monadic classical logic. This means that the only predicates that we will have are monadic predicates like cat, tree, microwave, hammer, and so on. But it will be two-sorted. And this means we will be able to quantify over two distinct sort of individuals, so to speak, namely objects and properties. And yeah, if time permits, I will compare this to other approaches. So this is the outline of the talk. First, an example, introduction, so what I'll do. Then formulation of the classical essentialist theory of kinds in classical logic. Then the core of the talk, namely natural kind semantics, and then comparison to other approaches. So here's the key semantic idea. If you get this, you are pretty fine with the rest of the talk. I will represent kinds by pairs of sets. Pairs A, B. So set A contains some objects. This is what we usually call the extension of the kind, which things belong to the kind. And set B is a set of attributes, which basically represents the essence of the kind. It's a set of properties common to the members of the kind. And so the condition that I will require is that every object in the extension has essentially, in the essence, every property in the general essence, and the dual condition, namely that every attribute or property in the general essence will be had essentially by every object in the extension. I will use the terms attribute and property interchangeably, but basically I don't want to use much the term property, namely because some people think that kinds are properties so in order to distinguish kinds from other sorts of properties, I will say kinds and attributes. Okay, so here is an example. There's some objects, namely a hammer, a car, a microwave, and a knife, and some attributes, which are some functions that these artifacts are designed to perform, and some structural features. So for instance, being designed for cooking, being designed for crafting, and some structural features like having wheels, being an electric gadget, and so on and so forth. So here's the summary. For instance, A is, well, I guess A is the hammer, used for hammering and used for crafting. And B, I take that is the car. It's electric and has wheels. Okay, so we now classify these objects into kinds of artifacts. And this is what I want you to focus on, please. So here is the set of all the kinds that we can get from here. On the top of the diagram, you have a kind called here artifact. An artifact contains in the extension everything there is in the domain. So the hammer, the car, and so on and so forth. And as you can see here, if you can see properly from the set of attributes is empty. So there's nothing common to all the artifacts. Okay? So just take another example. Kind knife contains just one object, E, in the extension, which is a specific knife. You can imagine you have the knife in your hand. And the essence is a set of properties. In this case, would be being designed for crafting, being designed for cooking. And so the diagram shows you which kinds are more specific than which other. So the kind knife is more specific than the kind crafting tool. I will go back to this later on. Okay, so some claims that are true in this model. This is just natural language, right? So yeah, true. For instance, every object is an artifact. We saw that, right? A, B, C, D, E, they are in the extension of artifact. No object is both a knife and a vehicle. Right? I mean, should be intuitively true, and it holds in this model. So, okay. An object is a microwave if and only if it is both a cooking tool and an electric gadget. Okay. So, here's what it will look like from the logical point of view. So we just translate these natural language sentences into logical formulas. For instance, everything is an artifact is represented as, just forget about this, simply means that it is true in the previous model, in the example. For every x, where x is an object, x is an artifact, right? So here is a monadic predicate artifact denotes the kind that I showed you before, the thing at the top of the diagram. And yeah, and this is true, as we saw. And there's some other examples. So for instance, there is no object X, which is a knife and a vehicle. And yeah, and you can just guess what it looks like. For instance, we can say things that are basically due to the two-sortedness of the language. So for instance, the property or attribute of being designed for crafting belongs to what you could think about the disjunction of the kind hammer and the kind knife. So if you take hammers and knives together in some specific way, you get a more general kind. And in the essence of this kind is the property of being designed for crafting. That's why hammers and knives have the property of being designed for crafting. Okay. Yeah, we can go back to the example if you want later on. And yeah, so I will focus mainly on this structure. The specific example I chose is not important. We could be talking about any other things, but the artifacts are kind of familiar things. And yeah, so the theory of kinds I will assume from now on is natural kind essentialism. There are many sorts of natural kind essentialisms. So we have Brian Ellis, Jonathan Lowe, Alexander Beth, and Thomas Taco. They all defend different sorts of essentialism. But they share some common assumptions, right? So the basic idea is kinds have general essences, and these essences basically fix the membership conditions of kinds. So the conditions under which something belongs to the kind. So here would be a way to put it. An object belongs to a kind if and only if it exemplifies essentially all the properties in the essence of the kind. Yeah, it's a plausible way to put the claim. And some other claim may be two kinds are identical if and only if they have the same essence. Not so important for our purposes, but yeah. So I will formulate this theory as a theory in the logical sense. What does it mean? Well, we take some set of axioms, namely those of classical logic, and we will add some more axioms to it just to get this specific theory, namely the essentialism. And then I will use the sort of structures I was talking about before as semantics for the theory. This is basically what I'm doing. Okay, so the language is that of first order monadic classical logic with identity, and it's two-sorted. So basically you take your usual understanding of classical logic, you just make the distinction between two sorts of things, so to speak. So we have symbols for objects and symbols for attributes. All right? So we use small letters for objects and capital letters for attributes. Monadic predicates, they represent natural kind terms, so they will denote kinds, and I will use this K, K prime, K prime prime, and so on for that. And then, this is the important part, I will use a specific symbol to get atomic formulas that say that some object has some property essentially, right? So we will write S blah 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 to say this has essentially this property. And that's it, that's basically it. So here are some examples. Yeah, so we can say things like C0 is identical to C0, but also things like, cats. Cats are animals in the sense that the kind cat is a species of the kind animal. I'm not quantifying over kinds, so this will be just an abbreviation of another longer formula. And things like, Socrates is essentially rational, or Simon is a cat, so there's a relation between objects and kinds, stuff like that. Okay, so how does this work specifically? These are the two axioms that I will add to deductive system for classical logic. You can think standard system. The first axiom is this, the axiom of membership conditions, and it says the following. These are the essentialist membership conditions for kinds, right? So it says, for every object X, X belongs to a kind K, if and only if for every property X, if the property is in the essence of the kind, then the object has it. So, put it in natural language. An object belongs to a kind if and only if it has essentially all the properties or attributes in the essence of the kind. Right. Plausible. Here's the second axiom. This is dual to the other. So we just replace terms for the other sort. So an attribute belongs to the essence of a kind if and only if it is had essentially by all the objects of the kind. And here's just how the whole deductive systems would be formulated. For instance, 1 to 5, and then 8 and 9 are just axioms and rules of inference for classical logic. So you just can ignore them. There's axioms for the universal quantifier, axioms for identity, then the two new axioms that I just told you about, and then just the rules of inference for classical logic. So just focus on 6 and 7, which are the new things. Okay, so that was the theory. Now you could think, well, okay, this looks like classical logic with some stuff. What are you talking about? Okay, because I want you focus on the semantics. That's the thing. The semantics I propose is based on a model suggested first by Richman Thomasson. So let's get into that now. Okay, so Thomasson proposed a model for natural kinds, in fact, and his model was algebraic. What does this mean? He presented an algebraic structure known as a lattice, that I will explain now what it is. And he said, look, what we can say about kinds is that they are structured in this way. They are structured as a lattice. And so, since they are structured as a lattice, we can combine kinds in some specific ways. Some specific ways of combining kinds are legit. They are okay. Okay? And so, for those who are not familiar with this, lattices are very, very closely related to logic. So, for instance, Boolean algebras are lattices. And basically, Boolean algebras, they give you the algebraic structure of classical propositional logic. So if you think about logical connectives, you kind of get a feeling that they have some sort of algebraic behavior. You have P, and P basically it's logically equivalent to P and stuff like that. And you could think about P and P equals P, or P and Q equals Q and P, and so on and so forth. And this is the algebraic structure behind the logic, basically. Okay, so in our case, I will describe lattices basically as these algebraic structures, but as defined by a specific order relation. And this order relation is the one that I depicted before, like with the lines in the diagram. And you can think about this as, K is less than K prime, if and only if K is more specific than K prime. So for instance, hammer is less than artifact because the kind hammer is more specific than the kind artifact. Okay? And we also have these two operations called meet and join that they look like conjunction and disjunction. So we can take conjunctions and disjunctions sort of kinds. Okay, these are not logical connectives. And so yeah, they work in this way. So kind K prime prime is more specific than the conjunctions of kind K and kind K prime, if and only if it is more specific than each of these two, right? So they behave like conjunction and disjunction, basically. There's no, you can get familiar to it. And so the meat is literally the greatest lower bound. So it's the most general kind that is a species of both. So if you take two kinds, then you look at the species of these two kinds, so the kinds that are more specific, like here, and you take the most general one. So in the diagram, you basically look for lines and see where they meet. That's it. Okay, and most interesting lattices have two special elements, which are the highest element, in our case, were artifact, so the most general kind, call it the summum genus, and there's also the lowest element, the one in the bottom of the diagram, and we'll call it the null kind. Okay. Yeah, so according to Thomason, kinds form a lattice, and this is a good starting point, but my main concern with this approach is that it doesn't tell us anything about the membership conditions of kinds, which was, different theories of kinds, essentialism, causal theories, different pragmatist views, promiscuous realism, and so on. They actually say something about under which conditions an object belongs to a kind. That's the main purpose. The main purpose of kinds is to classify stuff. If you don't tell me under which conditions objects belong to kinds, then the approach is kind of too silent in this regard. And usually, and most of the theories talk about something that is common to the members of the kind. And saying that kinds form a lattice is, doesn't say much about this either. So instead of using, arbitrary lattices, I propose to use a specific kind of lattices from the theory of concept lattices by Rudolf Will. It's a very, lattice theory is just a sub-branch of lattice theory, so it's a well-known theory. There are some authors that already propose something like this, like Moman, for instance. And I will use this to provide a formal semantics for the theory. Okay, so here's the basic definitions. A skeleton is a structure of the following sort. We have a set of objects, S, a set of attributes, Q, and then there's a relation between both. And the relation is that of essential exemplification. So we have an object, and we say this object exemplifies this attribute essentially. And that's, I require this. Nothing is both an object and an attribute, hopefully. Yeah, so example 2 is the one that I told you about before. So we have a set of particular artifacts and then some features, structural features, the functions they perform, and stuff like that. Okay? Now, here's an important notion. If we take a set of objects, we want to consider the properties that are common to all these objects. And for that, we have a function. And so the function says, take a set of objects A and give me the set of properties or attributes P from a set Q, such that every object has this attribute. And let me call this basically the essence function. It gives you the essence of the set of objects. And then we have the dual. So we take a set of attributes and say, give me the set of all the objects that have all these attributes. And call it the extension function. So if you take a simple example, take a set that includes only one object, and I will give you the set of all the essential properties of the object. Take a set that only contains one attribute, I give you the set of objects that have this attribute essentially, so the extension of the property. Right. And now this is a crucial move. We represent a natural kind as a pair of sets, A and B, a set of objects and a set of attributes. And we require that A is the extension of B, and B is the essence of A, so the set of all properties that are common to all the objects. These are the standard definitions. Of course, Willy doesn't call them natural kinds. He calls them formal concepts, but yeah. Okay, so that's the basic idea. Now we can go on checking, that the main theses of essentialism are preserved in the model. And so, for instance, an object belongs to a kind if and only if it has essentially all the properties in the essence of the kind. That basically is the axiom of membership conditions I gave you, and one could check that this is actually valid under the definitions that I haven't given you yet of validity and so on. And the dual is true in every model also. So an attribute belongs to the essence of a kind if and only if it is had essentially by all the objects in the extension of the kind. We can define also this specificity relations between kinds, so under which conditions one kind is more specific than another. So a kind is more specific than another if and only if whatever belongs to the first kind belongs to the second. Right? So K is a species of K prime if and only if an object belongs to K, it also belongs to K prime. I will go back over and over this stuff, but yeah. And we can also preserve essentialist identity conditions, so under which conditions two kinds are identical, which is not something that I can formulate in the object language because I'm not quantifying over kinds. So this is a metalinguistic claim. But natural kind terms that denote kinds with the same essence will be denoting the same kind. So that, in this sense, I'm saying it is like saying that classical predicate logic gives you extensional identity conditions for properties. There's not something you can say inside the logic because you are not quantifying over properties in one sorted case. But the semantics tells you that two predicates that correspond to the same set of objects basically denote the same property. And yeah, so there's a theorem, standard theorem in the theory of concept lattices, that if you take all these pairs of sets and you give the definition of this species genus relation, so the specificity relation, then you get a lattice. The algebra I was talking about. It has a conjunction-like operation, a disjunction-like operation here, there. And it has a most general kind and most specific kind. So for instance, if you want to get the conjunction of two kinds, you basically you intersect their extensions. So whatever belongs to both kinds belongs to the conjunction. And you take the essences of both kinds, you put them together, and you add whatever properties are needed. So if there is a property that is had by every object that belongs to both, even if that property is neither in one of the essences or the other, then it belongs to the essence of the conjunction. All right. And you can see this again in the original example, right? So knife, the kind knife is the conjunction meet of kinds crafting tool and cooking tool. The kind microwave is the conjunction of cooking tool and electric gadget. Electric gadget is the disjunction of microwave and vehicle. And then we have the kinds artifact and the null kind. And yeah, this is basically what I said. And now we can basically use this to provide the formal semantics for the theory. So we just define what is for a structure to be a model of the theory. And to that, we just basically define an interpretation function. So if we have an object term, we send it to an object. And if we have an attribute term, we send it to an attribute. And in the case of kinds, so if we have a monadic predicate, K, we just send it to a pair of sets in the lattice. And that's it. And we define truth in the usual way. So for formula object T exemplifies essentially attribute T, big T, if and only if the denotation of the term of the object term exemplifies essentially the denotation of the attribute term. Right? So it is true that kt, so little t, satisfies predicate k if and only if the object denoted by little t belongs to the extension of the kind denoted by k. It is true, that an object belongs to a kind if and only if the object belongs to the kind, basically. And the same for attributes, right? So here we require that big T is true if and only if the denotation of T belongs to the essence of the denotation of K. And the rest of the truth conditions are just classical, just usual thing, nothing fancy here. Okay, so you then define validity, semantic consequence, and so on and so forth. And I got the following result, mainly, which is a completeness theorem. So the semantics is complete with respect to the theory. The proof is basically Henkin's proof, but there's a step where you have to construct the canonical model, and the canonical model here is a structure that induces a lattice of kinds. So you have to check that is satisfied, that you are actually, the terms actually get interpreted as elements in the constructed lattice of the canonical model, and that's it. I'm not going into the details here. Right, so there's two sort of nice things you can do with this. First, talk about the specificity relations between kinds, and talk about operations between kinds, which is, again, what I was mentioning before. For instance, here we are just in the logic side now, not in the more language side, not so much in the semantics. So we can define, for instance, K is a species of K prime if and only if for every object, if the object belongs to K, then it belongs to K prime. Or we could say, K is a species of K prime if and only if for every property or attribute X, if it belongs to the essence of K prime, then it belongs to the essence of K. And these two are equivalent definitions. So it can be proven that these are equivalent in this theory. I will go back to that now. There's other stuff you can do. For instance, sort of say what sort of shape the diagram of kinds has, what shape it has. And one shape it could have is this. So here is a tree. Probably well known to all of you, this is Pophillian Tree, right? And there's many domains in science where classifications are hierarchical in this sense. They sort of kinds form a tree-like pattern. But this is not always the case. So some philosophers of science, for instance, Emma Tobin, they famously argued that this is not the case, and they gave explicit counterexamples like the following. Right. So in this case, this is not a tree, because as you can see, these two branches mesh here. These are kinds of biomolecules, and it turns out that there are things that are both proteins and enzymes. This is the example that Tobin gives. So you don't have a tree because there's some branches that overlap here. And my point is simply that you can use the semantics to say, with the axioms I gave you, if you take these axioms, the following formula is not valid, and by completeness is not a theorem. And you can check for counterexamples. This would be literally a counterexample, a model counterexample. But there are some formulas that are theorems. And these formulas are also about these species-genus relations. And one of these formulas is Kant's law. And Kant's law, it's called like that by different authors, including including Peirce, and I think John Stuart Mill. Well, you can just don't take my word for that, but if I remember well, that was it. So the formula says, the bigger the extension of the kind, the smaller the essence, basically. So the more objects belong to the kind, the less they have in common, and then vice versa. The smaller the extension, the bigger the essence. So the fewer members the kind has, so the more specific it is, the more they have to have in common to belong to the kind. And this relation is basically what the formula expresses. And this is a theorem. So if you accept the two axioms, you have to buy this. OK. And here is another application. I was talking about conjunctions and disjunctions of things. And I told you, if you take two kinds, you can look at the conjunction kind, and you can look at the disjunction kind. This always exists. But that was from the point of view of the semantics. So the question would be, could you express this in the logic? And yes, of course. There are several ways. The simplest one is by abbreviations of formulas. And the thing is, there are more operations besides these conjunctions and disjunctions. So these conjunctions and disjunctions are sort of a standard. But there are other operations that I discuss in the paper, namely operations that look like conditionals and differences. So you can take differences of kinds, and also negations, right? So here it would be the way to formulate it in the logic. For instance, an object X belongs to the conjunction of two kinds if and only if it belongs to both. Okay? But if an object belongs to the disjunction of two kinds, if and only if it has the properties that are in the essence of one and in the essence of the other. And you cannot just simply say an object belongs to the disjunction of two kinds if and only if it belongs to either of them. So this is not true in the model. And there's other operations like negation, here difference, and so on. And so an object belongs to the null kind if and only if it has all the properties, essentially. And then everything belongs to the sum genus because everything is identical to itself. Okay. And so the interesting point of view, from the philosophical point of view, the interesting fact about this is that you can make a very fine-grained distinction. So, for instance, this is an instance of excluded middle. For every object X, it either belongs to K or it is not the case that it belongs to K. For every object, it is the case that it is a cat, or it's not the case that it is a cat. But you can say things like this. The previous one was a theorem, this one is not. This one says that an object either belongs to a kind, or it belongs to the negation of that kind. And so this is not just simply saying that it does not belong to the first kind. Okay? And basically, I was not going through the details about the definition of the negation, but the idea is this. This fails because there are some objects that have neither all the attributes in the essence of K, and they don't have all the attributes in the essence of the negation of K. So one example, this. I think this is by Aristotle, but I'm not sure about that. I have some doubts, but so objects that are not alive or cannot be alive are neither mortal nor immortal. So you can think about the negation of a kind as being denoted by something like a contrary term, not a contradictory term. Okay, and there are some other stuff, interesting stuff about the semantics. So just finally, I want to compare the approach to other two approaches that one could use to talk about kinds. The first one is Martin's Aristotelian syllogistic logic. This is a modern approach to syllogistic logic, quite nice. And it's based on previous work by Corcoran and Smiley. And so the idea is the language is more or less like a propositional language. You have syllogistic terms, A, B, C, and so on. So you could think of this as denoted kinds. And we have 4 symbols that basically represent the relations between propositions according to the quantificational square of opposition. So the idea is, big A, little b represents all A's are B's. So if you recall the Aristotelian square of opposition, right? A, E, I, O, you get these relations between propositions, and this is what is preserved by the logic. So big I, little b represents some A is B. Okay, so this is nice to explain syllogistic reasoning, and it's pretty Aristotelian, so you would think, why not think about this as a better logic for kinds? Talking about species and genera from an essentialist point of view, so why not? And in fact, the complete semantics is given by semi-lattices. So the point is that this is not expressive enough. So the logic is propositional, so it doesn't allow you to talk about identity and quantification statements. You have to represent everything as a kind, so objects too. Secondly, it doesn't tell you much about the species-genus relation, so hierarchy, Kant's law, and so on. And thirdly, there's no obvious way of expressing the operations between kinds that I told you about. And for me, this is a problem because these operations basically follow from essentialist actions. All right. Then there's also a work by Freud on logics of sortals. This work was started by Coquerella. And in contrast to the syllogistic one, these are predicate logics. So you could think, well, maybe you can sort of solve some of the problems that the other logic has. And in fact, it is a very, these are very interesting deductive systems. They allow you to make distinctions, between relative and absolute identity, sortal and non-sortal quantification, and things like that. But from the deductive point of view, I'm not going to talk much about, but from the semantic point of view, I still find them problematic. So the semantics of these logics of sortals are Henkin semantics. So basically, you would take a natural kind term and you would map this to a set of objects, and that's it. So you would not have what I was talking about, which is a set of objects and the essence, and the relation between the two. So in this sense, it is less, less similar to what essentialists are talking about. And this has some consequences. So for instance, Freud does introduce sortal restrictions, which can be used to talk about species-genus relations between kinds, but he doesn't say much about this, and it's not clear how interesting theorems follow from these formulas. In contrast, the semantics I propose, basically allows you to talk about hierarchical relations, Kant's law, and so on. And this structure is basically related to the algebraic operations I was talking about. Then essentialist membership conditions do not appear, basically because the logic does not have means to talk about the properties that are common to the members of the kind. This does not appear in the semantics, as I was saying, but what the essentialist membership conditions are directly reflected in the axioms I gave and in the corresponding semantics. And finally, the same goes for the operations. So the algebraic models I was talking about, they have operations between kinds that are not just Boolean set-theoretic operations. So remember the join case different from the union. And the operations I give, they preserve the essentialist definition of kinds, right? And so, that's basically it. So summing up, I provide a complete natural kind semantics based on the theory of concept lattices for an essentialist theory of kinds in monadic to sorted classical logic. And I argued that this semantics is better for explaining natural kind essentialism than some other proposals. And that's all. Thank you for coming to this.
Great. Thank you very much. So, time for questions, comments, doubts. Go on.
So I have two, I think, pretty naive questions. One is something I didn't understand, and the other one is kind of philosophical, more general. So I'll start with the complete one, if I can, otherwise if there are no questions. So in the slide where you put, I think, so you have this theorem, I think, and you said, well, it's not good because it would lead you to a tree-like structure, and you have the counterexamples with the lattice.
Yes.
I didn't quite get that. So that was a theorem. Maybe I was instructed, but I didn't.
Yes.
That one exactly. So what? So this is.
This is not valid. So it is true in some models, but it's false in other models. So it does not follow from the essentialist theory as I formulated it. Yeah.
Okay, but it's okay.
So it's true only in some models like this one, but it's false in other models like this one. And this is interesting because some philosophers have argued that it is, that this is an actual counterexample to the.
Counterexample in that model to that other thing. Yeah. So I guess so this is connected to my general question. So okay. So you presented here in Semantics approach for a classical essentialist view of natural kinds, and I was wondering. This is a very naive question, right? So it's general, but it's naive. About the flexibility of your view, like say, could you accommodate something like a promiscuous realism or something like that within this? And I guess it's connected with that. So some of the theories would be true for some model, but not for an essentialist model. Or how does that work?
Yes, so that's a really good question. As I presented it, I put it in the clothes of an essentialist theory. But if you basically take the atomic formulas of this form and call it something else like exemplifies and forget about essence. If you take this and forget about essence and put X, for instance, and you have an object exemplifies an attribute if and only if in the skeleton the object exemplifies the attribute. Then there may be some theories of kinds that do not have such strong commitments as essentialism, but that they would agree with this new interpretation of that and could agree with the axioms, the two axioms I gave you. Now, I don't know, maybe I say that an object belongs to a kind because I stipulated it, and my stipulation gives you necessary and sufficient conditions, and there's nothing about the nature of the object that makes it belong to the kind. And previous stuff reinterpreted would be true. But some other theories are not compatible with the reinterpretation of the whole logical system. So for instance, causal theories are not. So this excludes causal theories, and the reason is that, let me go to the axiom, well, here. Okay, so causal theories would reject that an object belongs to a kind if and only if has all the properties that are somehow related to the kind. Because they would say, an object needs not have all the properties that we associate with the kind, maybe because there's some causal mechanisms that make these properties go together. This is Boyd's theory. And so they would reject this. They would reject this axiom. So there's no way you can reinterpret this to get a causal theory of kinds. I don't know about promiscuous realism because I'm not sure that Dupré would agree with saying, that an object belongs to a kind if and only if satisfies some conditions. I think he's pretty fussy about that, so I don't know. I would tend to think that no, that he would allow cases where objects belong to kinds if and only if, even if there's no necessary and sufficient conditions to be satisfied. So these theories would exclude it, but as I said, in principle, the whole machinery could be compatible with other theories. Now, that being said, among the main theories of kinds, most well-known ones and the ones that have, some pedigree, there's essentialist causal theories, promiscuous realism, and then some pragmatisms. And so if you look at this, then the one that best suits the whole structure is essentialism. And we have some other reasons in favor of essentialism, so we can explain some other stuff by using essentialism, like quantitative change, identity conditions for objects and stuff like that. So yeah, that was a good question. Yeah.
Well, I have never heard about those things, so thank you very much. But I have a very simple theoretical classificatory questions. But so when you are not referring of, for example, the kind of being a chair or something like that. It's like it's a set, but we don't have to name that set necessarily. Like, for example, if you have that chair has some attributes, but you have one that doesn't have it, and you have A that would be the set of the chairs that share the essence. Like, for example, not having, I don't know, well, maybe chair is not the best one, but instead of having 4 legs,
yes,
it has only 1 or something like that.
Like, yeah.
So you would have that, even if...
So let's buy into essentialism of artifacts. I mean, there's several steps we have to make first. And then, so suppose that there is actually an essence of chairs, which may not be, the example I gave is pretty naive. So you could say something can be a car without having wheels, maybe, I don't know. So if there is an essence of chairs, common to chairs, like some essential properties that make something being a chair, if some chairs do not have 4 legs but have one leg, then that's not an essential property common to the chairs. So it will not belong to the essence. And so, the definition would hold, but for other properties, maybe, I don't know, being designed for having someone seated over it, right? So there's, you could say, maybe some things that were not designed for that, but are still chairs, maybe, or something like that. But yeah, but there's another point, it's an important point that of something you mentioned, and yeah, so this may be a bit confusing. I'm using a pair of sets to represent kinds. So there's 2 things here. The world has kinds, whatever they are, and this semantics uses sets to talk about these. Well, it uses sets and then uses predicates to talk about the sets, to talk about kinds. And these are different things, I would not commit to the stronger claim that kinds are literally pairs of sets. That this is not what I would say. But this is like saying we can use sets to represent properties. Maybe you are a nominalist, you want to say no, properties are literally sets. But this is not something that I will put now here. And yeah, don't know. Does it answer?
Yes, and another one. Okay, but like, I'm sorry, those are like super active, but you said that. Okay, I know what you mean, but things can be an object or an artifact. But I was thinking I'm thinking in literal language, like when you say X is a woman. Like, I think I'm missing something, or maybe it's because you are defining the individual by the attribute.
Yeah, that's it.
It has, or yeah, yeah.
So you are, I guess you're wondering how does this apply to
yeah.
things like woman, or maybe even more controversial races.
Yeah, and how do you pick and how do you pick
the essence if there is one, right?
Yeah, but maybe you are not.
I would, of course, I'm not making claims about whether essentialist theory is applicable to social kinds. I mean, some people think that it does. But even if it does, I haven't told you about what the essence would look like. Maybe there's some social processes that make someone a woman. I mean, extrinsic properties, relations, social processes, not necessarily biological features, or maybe there's some historical processes. Of course, you would say then, does this mean that in every possible world this person is subject to the same social processes? We have to talk about what do you mean by possible? Do you mean nomologically possible? And if that's the case, then are we talking about laws in social sciences and so on? And that would lead us to a deeper discussion that I cannot go into now because I don't have the tools. But there are several ways to answer that question. One, there are no essentialist social kinds, so the theory is not applicable. That would be one way. If you are skeptical about this, then probably why not? Two, essentialism is applicable, but maybe the properties are not what you expected. Maybe they are social relations, or institutional facts, or whatever. So, for the time being, I suspend judgment of that, but I give you this in case it may help illuminate the point.
Like Maria had a bunch of your particular questions that are probably silly because or things that I didn't very well understand, or this system is new to me, so I didn't have. This was quick for me.
Yes, it was.
And then I have Maria, one more general question about the project. Let's say a more philosophical question. Okay, a more general question, which is maybe naive, maybe a bit silly, but which affects to the project. Okay, so first, two particular questions concerning the system, if I may. First, are in this system kinds themselves essential attributes? Because if I got your language correctly, you cannot say that, I don't know, Pincho is essentially a dog. I mean, you have the operator S, and there you can have a particular, and the attribute, the second set, that you link with the natural kind. But as you define it, if I remember it right, because
that is absolutely correct. That is absolutely correct.
Right? I mean,
because you want to say things like that, right?
I mean,
yes.
I mean, that's weird. I mean, it seems to me that an important part of natural kind essentialism is that natural kinds are essential to the objects. That essentially human, for example.
Well, or at least necessarily, yes. Or at least necessarily the case. Yeah.
So, well, that was the first particular question. I mean,
yes.
And the second one, can there be two different natural kinds with the same extension, but a different set of essential attributes? Because it seemed to me that there is room for that. But again, that sounds weird.
There cannot be. So, let me answer the second one. Yes, pretty good questions. So for the second one, if two kinds have the same extension, then they have the same essence, and they are the same kind.
Why? I mean,
which you probably don't want to. Yes. So there's so I have the short answer and the long answer. The long answer I prefer not to go into. I discuss it in the paper. But the short answer is, if you want to have kinds that have this is modally frozen. So this gives you the actual world. so to
Sorry,
speak.
again?
This is modally frozen. So
Yeah, that's my
that only talks about, one possible world, so to speak. So you cannot have, things like a kind could have a different extension in different possible worlds, because this has no modality here.
Okay, but that wasn't my question. I mean, the thing is that it seems to me that in your system, it is possible to define two different kinds. I mean, to define a kind, you need two sets. The first one is
yes.
And the second one with attributes.
And they have to be suitably related.
Okay, I lost that. Okay.
Yes, you have to. Yes, so the extension needs to be, so A needs to be the set of all the objects that have essentially all the properties in B.
Okay.
And the essence needs to be the set of all the properties that are had essentially by all the objects in A. So it's not just a pair of sets, it satisfies the additional constraint that they are well related. I didn't say this in the first slide because, probably did, I don't know, but I didn't go into the details because that was a bit too much for the, but here is the definition is this one.
Okay, and then my question is, why can't I define two different kinds
Yes.
that have exactly the same A set as an extension, but two different second sets as essential properties?
You say that this is possible here, or why I can't do? No, that's not possible. If you have the same extension, then they will have the same essence.
Why? I mean, that should be a theorem then.
That's what?
A theorem. I mean, you should be. I mean.
That's a theorem. That's a theorem. What I said is a theorem about the semantics.
Okay.
But you cannot. I mean, in order to formulate that in the logic, you would need to say k is identical to k prime. You cannot do that because I'm not quantifying over kinds. But you can prove that in the semantics, so in this mathematical structure, if the pair A, B and the pair A prime, B prime have the same extension, so A is equal to A prime, then B is equal to B prime. So if they satisfy this definition, you can show that. And the reason is that if you define this order relation, species order relation between two kinds, in this way, as inclusion, this can be shown to be a partial order. So it is antisymmetric. This means that if this is related to this and this is related to this, then they are identical. And these are pairs of sets, right? So if so this holds if and only if this holds. If it holds in the other direction, then A prime is included in A, and so we have A is included in A prime is included in A, so A and A prime are the same set. But this is a partial order, so if it holds in both directions, then the pair of sets are identical, and so if the pairs of sets are identical, then the components are identical, so B equals B prime. They have the same essence. I mean, I could give the details, but probably you won't be interested. I guess, like, my feeling was that you were, or maybe I misunderstood your question, but I thought you were thinking, but why can't I have two kinds, they have the same essence, so the same kind, but have different extensions? I want that. I want the extension to change from one possible world to another. And that I cannot give you.
No, actually, my worry was the contrary one. That
okay.
It seemed to me that it was possible.
No, it's impossible. It's impossible. I mean, it's a mathematical fact. So, I mean, in the semantics, but I cannot express that in the language. Right? And the other question was.
Natural kinds don't seem to be essential.
Yeah, there's no way to say Picho. Yeah. Okay, you cannot say that. That's correct, because the atomic formula only matches objects and attributes because I'm not quantifying over kinds. So that's not something you can say. And
weird, right?
It's weird, yeah. So there's no way to make explicit Kripkean claims. Kripkean essentialist claims like, if X belongs to K, then it is necessarily the case that X belongs to K. one way of solving that problem is to make this model, introduce modal operators, because this is classical, and then you make the modal operators behave nicely with the essence atomic formula.
Okay, so if I may, because that was my general worry. I mean, what about necessity?
Yeah,
We talk about essence here, but
yes.
it seems to me that, you know, essence essentially has to do with necessity. That, I mean, this system doesn't explain or reflect that essential properties are
necessarily the right properties. Yeah, it doesn't, because it's not non-modal.
Okay, but shouldn't it? I mean, that's my general worry.
Then, yeah, but then that would be more work. So that would require introducing a modal operator, which I'm trying to do. But just to mention, more expressivity is nice, but it leads you to a lot of philosophical trouble. So you have to then choose which semantics for modal logic you want, and then the ugly monster appears. So are you a necessitist? Are you a contingentist? You know.
Okay,
and maybe you have to choose between classical logic and free logic and stuff like that. And so these are other philosophical problems that I didn't want to deal with.
The necessary character of essence, let's call it like that, will be explained by a modal semantics.
Yes, you would need to include possible worlds, so lattices of kinds for each possible world and things like that. But a lot of trouble, so you say. I mean, there's a lot of stuff there. Yeah.
So, just to comment, one of my question with promiscuous realism or something. So one thing you could say is, well, in a sense, it's an advantage, because if you don't have an advantage, I mean to say, it gives you a bit more flexibility, because you don't have this modally strong notion of essence. So you just have like a set of properties. So I'm just saying that is why I thought your semantics was not essentially linked with essentialism, because you don't have the modal definition of essential. What is essential? You just have a set of properties, and you have to make sure that all of the objects have all of the properties. Which, again, it seems like it's not essentialism.
Yeah,
That's my point.
that's not like essence.
Exactly.
It
so
has.
It gives you more flexibility, maybe, I don't know. That's,
Sure, yeah, but it's not essence.
but it might be natural kind. Even if without the necessity, still we might say it is a natural kind. But the problem maybe is that you are saying essential and then...
Yes. So the notion of essence I'm taking here is, you know, it's essence goes first. Essence is primitive.
Yeah.
And then if you want, we talk about necessity. If you want. I mean, I understand, you know, you want to make Krugkian claims. But yeah, this is not expressible here as it stands. But it can be augmented to get a modal logic. It's a whole lot of trouble, but it can be done. Yeah, so yes, I see the link between both questions. That's it, yes. So it's more flexible at the expense of not talking about the relation between essence and necessity. And yes, once you do that, you exclude, if necessity is interpreted adequately, you would exclude non-essentialist readings of the theory, like purely stipulative readings, you know, because that would not be necessarily, you would have to interpret the modal operator of necessity, and it's not clear what sort of necessity would be that. You know, just stipulating something is not something linked to necessity. But yeah, that's a way to, yeah.
Yeah, about classificatory question as well. When you have talked about the philosophical implication of your theory, you said that one of the advantages is that you can talk about negative kinds or opposite kinds, or I don't remember. Can you explain a little bit that point, because I don't quite get it?
Yeah, so I went very quickly over that. Yeah. Okay, so let me find it. Yeah, so this won't help you. The thing is that, you know, in a lattice, in a general lattice, you have conjunctions of things. So in this case, lattice of kinds. We have conjunctions of kinds, and we have disjunctions of kinds. Some lattices have also a very, like the highest element and the lowest one. Okay. Now, that's as far as we can get with regard to things that look like logic in a general lattice. It turns out that some lattices have a bit more structure, and some operations are defined over them that go beyond conjunction and disjunction. And in this case, would be negation-like operators. So this is not the best way to see what the negation does. And the problem for me is that I have two negations, so I always conflate both. But one, basically, what it does is takes the properties that are in the essence of. So yeah, let me go to the difference and the conditional here, and then these are special cases. So in one case, you take the properties that are in the essence of one kind, and you take the properties that are in the essence of the other kind. You remove them. And then you just take the objects that are needed in order to have a kind, because you have to make that a bona fide set of essential properties, and you get a kind if you do that. And the more interesting point is that the resulting negations behave non-classically. So that means excluded middle fails, as in the example. Where is it? Yeah. So it may be objects that belong to neither one kind nor the negation, as in the mortal or immortal case. So stone is not immortal, stone is not mortal, so it doesn't belong to any of them. I mean, you would have to buy, for example, Essentialism about mortality or immortality. But yeah, that would be the idea. And so the other negation, for instance, would go in a different way. So it would make, so non-contradiction would fail for that negation. And you would have things that belong to both the kind and to the negation of that kind. So let me give you a bit of a maybe not so convincing example. Someone can be a buyer and a seller at the same time. And there's a sense in which buyers and sellers are opposite in some way. So seller, is in some sense the negation of buyer, but some things can belong to both kinds. And that would be an example of that. The thing is that this doesn't damage classical logic. This is still classical logic. So excluded middle holds for negation, but something like excluded middle fails for negative kinds. And this is because this negative kind is not defined in terms of the negation. It's not the case that an object belongs to the negative kind if and only if it does not belong to the original kind. That doesn't hold. And the reason is that the extensions of kinds are constrained by the essential properties. So there may not be an essence that is common to all the things that are not case. That's why it fails. So you take the cats and you look at the things that for which it is not the case that they are cats, and there's nothing essential in common to all of them. That would be one example. And they do not form a kind because there's no essence common to all of them. But there is a kind that behaves like the negation of that kind, and that one satisfies the definition. In some models, it's trivial and it's not interesting. In some other models, there may be an important difference. So it may be, the opposite kind in some way, in some sense. But I need to give you more details about this thing, and I couldn't. More clear? Or?
Yeah.
Okay.
More questions?
I have one question about the diagram.
Yeah. Which one?
No, I mean, I was thinking the first thing on the top in the diagrams
Yes.
is a kind,
Yes.
right? And a kind is the pair.
Yes.
So in that one, you have the objects and no essence.
Yes, and I think that...
And in the bottom, you have just the opposite thing.
Wait, I think I have one more object than I needed because I corrected this thing, so...
Yeah, but I was thinking in the structures.
One of them is a cheater.
The
Yeah.
essentialist model gives you always a structure that goes from a kind that has all the objects
Yes, yes,
and
yes,
no
yes.
essence to a kind that has no objects
Good question.
but to essence.
Yes, good question.
Every diagram will turn out with this structure.
So every diagram would look...
Will go from the top to the bottom to
Yes, but there's...
only objects, no essence to no objects to all essence.
Half of what you said is true and the other half is not. So the most general one contains all the objects, that is the case, but it may have non-empty essence because there may be properties that are essential to all the objects in the domain. It may be the case that these are not interesting examples, so you may tell me, Javier, you need an axiom that excludes this, but then we would need to, say, well, is this a commitment of essentialism? And I don't know, but I would be very much in favor of putting one more axiom that excludes that case, if it is the case that the essentialist could accept it. And dually for the other guy here, the one on the bottom, the essence contains all the properties. The extension may not be empty. So there may be an object that has all the properties, essentially. That is not usually the case because some essential properties are incompatible. So that for some specific domains, the essential properties are incompatible. And so in that model, the extension will be empty. That's usually the case, the extension will be empty. So here you collapse. So in the case of the actual world, every empty vacuous kind of term goes here. Maybe that's there.
So every object, necessarily every object belongs at least to a kind.
Yes, the summum genus.
Yeah.
Well, necessarily,
Why?
yes.
I mean, is that a condition of the models, of construing the models, or?
That is a consequence of the definition of a kind, yes.
A kind.
Of the definition of kind that I gave you, the idea that they are pairs of sets with extension and essence, and so on.
It doesn't follow. I mean, it follows
Yes,
that
it follows.
every kind has an extension, but it doesn't follow that every object in the universe has to belong to a kind.
There will always be a kind. And every object will belong at least to the most general one.
So that would be like the domain, right?
It's the kindhood. It's the kindhood representation of the domain. It's the kind that corresponds to the domain.
Okay.
Yes, in a sense. Yes. I mean, you still have to distinguish between the domain is literally a set of objects. The domain is represented as a set of objects, and the kind corresponding to the domain is represented as a pair of sets. So we are not using the same thing to represent.
And why can't you have an element in the domain which is not a member of the kind? Why can't you?
That is not a member of any kind.
Yeah. I mean,
You want that, or you just...
I mean, in classical predicated logic, in model theory, you can have elements in the domain which are not in the extension of any property. Why can't you have that here?
Of any property.
Sure, classical logic.
Well, not being identical to itself would not count as a...
Well, that's not a property. I mean, that's not. I mean, identity is not a property.
Yeah, well, let's take it a logical symbol, and then it's not a predicate, and so on. Yeah, well, it doesn't happen here.
Sorry?
It doesn't happen here. If you were to classify a domain of objects, would you get rid of stuff that you would not classify over any sort of box?
You can write such a model. I mean, this is logic.
But not, I mean, you could formulate a different theory that does not entail that, and this theory would have as a model the proposal you are making.
Okay.
But this theory entails that every object belongs to a kind. Yes, so that will be a different theory. But let me go the other way around. If you bought classical logic and you bought the two axioms, then every object belongs to a kind. And that is a theorem. So if you want that, then you have to reject either classical logic or one of the two axioms. And you can do that.
Can we see the two axioms?
Yes. I want to.
No.
Yeah, so this is the first one. Okay. Yeah, so this is the formula, and this is the natural language reading. An object belongs to a kind if and only if it has essentially all the properties in the essence of the kind. This is the closest you can get here, I mean, given this language, given this theory, and so on, to the basic claim of essentialism. Yeah. This is the other axiom. Maybe you want to reject this one.
I mean, it's not that I want to reject it. I mean, I forgot about the axioms.
Yeah, no. So this goes the other way around. It says an attribute belongs to the essence of the kind if and only if it is had essentially by every object. So if you take all the objects that you would say belong to the kind, if there's a property that is essential to all of them, then it's in the essence.
And does it follow that for any object, it has to belong at least to one kind?
Yes.
From those two axioms?
Well, when you say, does it follow that for every object, I take it that you say, does it follow that for every object there is a kind such that the object belongs to the kind? No, because there's no way to quantify over kinds.
Yeah, okay, but
so there's...
it's a meta-semantic question if you want. I mean,
yes.
Does it follow that you cannot define a model in which you have, in whose domain you have elements that do not belong to a kind? Does it follow?
Yes, it follows. There's no way you can have that. If yeah, so take that object. Now take all the properties that the object has. And now take all the objects that have all these properties. That set includes the object I'm talking about and satisfies the definition of pair of sets, and therefore is a kind, and therefore the object belongs to the kind. So you can see it like by steps. So we take the object x. Now take the set that includes x. Now take the set of all the properties, essential properties of x.
Would it be empty set, for example?
Well, but it could be the set with only that object.
Yeah, but it could be the empty set. Yeah.
With only one object.
Let's.
But in this theory, that object would satisfy the properties that it has. So maybe it would be a kind with one object. What he's saying, or something like that.
Yes, let's finish that. Yeah. Let's finish that. What do you want? More objects or just one object? It's just no. It's just for making the example explicit, but it doesn't matter. If you want this to be empty, maybe no properties. Okay, so no properties. Now we take the extension of this. So the extension of this is the set of all the objects that have all the properties that are in here. And this set includes x. And probably over there stuff if there's other stuff.
Okay.
And now I tell you that this is a pair of sets that satisfies the definition of kind. And there you have it. So one way, no, it's a good question why it holds. The point would be, Well, you take the object and then you look at its essential properties. If there's any essential properties at all, you take all of them, and then you introduce the objects that also have these properties, and then you have the kind. Let's say there's no properties that the object has. It has empty essence. Why not? Empty essence. Then you still get the pairs of sets, because you take all the objects that have empty essence, and then you get the definition. Right. So yes, this is proven.
Great, thank you.
Yeah, that's good. Yeah. So let me. I mean, it's a good question because it leads to other stuff. So if you take an object X and you take the essence of X, and now the extension, right? I told you this gives you a kind, right? Here is the kind. So the kind is quite nice because it contains X, all the essential properties of X, Socrates, all the essential properties of Socrates, and then every object that has all the essential properties of Socrates, and possibly more. And so this is like the most specific kind to which Socrates belongs. Infimum species. in the tree, in the tree, Pophillian tree, the ones at the bottom, these are these ones. So I don't remember the Porphyrian example. By the way, the Porphyrian. Where are you? Here it is. So this would be in this case, because the tree does not distinguish anything more. I mean, tree. You have here the null kind, the most specific one. I didn't draw it because it would confuse everyone. But yeah. Yeah. What else? I can give you an example of the negation later in the other explicit example. Like, yeah, because these ones are not so great to do that. Yeah.
More questions, comments? No? So maybe we can leave it here. Thank you very much for the talk.